Okay, the 2016 number 6 on the BC exam, and the last question on the BC exam is always a series question. We have a Maclaurin series. They give you the summation formula and the first three terms along with the general term. And question A simply asks you to find the radius of convergence. Now that's kind of nice because we don't have to go all the way through the interval of convergence. So we'll do the limit as n goes to infinity of the absolute value of the n plus first term, which would be negative 3 to the n, x to the n plus 1 over n plus 1 times n over, now this is my nth term, negative 3 to the n minus 1, x to the n, and then we start reducing. I have one more negative 3 on top than I do on bottom. I have one more x on top than I do on bottom. And so we are left with the limit as n goes to infinity. The absolute value of negative 3 is 3. X will remain in absolute values. N is already positive, and n plus 1 is already positive. And remember, this is a limit. The limit's a function of n. So my top degree and bottom degree of n are equal. We'll divide the coefficients, and we get 3 absolute x. And the limit, or the ratio test, shows convergence when the answer to the limit is less than 1. We'll solve for the absolute value of x. And when you get the absolute value part by itself, then whatever the absolute value is less than, that number is the radius. So the radius of convergence is 1/3. And you are done with part A. You are not finding the interval, so do not go through the hassle of testing your endpoints. So B, right, the first four non-zero terms for f prime, and they gave us the first three terms for f. I'm going to go ahead and find the fourth term as well. So we're starting where n equals 1. So that's n equals 1, 2, 3. I need n equals 4. So if I do n equals 4, my original fourth term would be negative 3 cubed, which would be negative 27 over 4 times x to the fourth. The reason I want to see the fourth term, I'm just going to do the derivatives of those first four terms. It does not ask for the general term. So f prime is going to be approximately, the derivative of x is 1 minus the derivative of 3 halves x squared would be 3x plus 9x squared. And then the derivative of my fourth term over here would be negative 27x cubed. Do not write plus ... because it asks for the first four non-zero terms, not the first four, and then insinuate that there are more after that. So I'm just going to stop there. And then it says express f prime as a rational function for x's within the radius of convergence. And so what we're looking for here is some kind of pattern, and the rational function, essentially it's kind of asking you to find the sum of this. So if it did go on forever, this would approach a rational function. And the hint in that it's a rational function is that the sum of a geometric series is your first term over 1 minus the ratio. So they're kind of giving you a hint that this should be in the format of a geometric series. And if you look at this from one term to the next, I'm always multiplying by a negative 3x. So 1 times negative 3x is negative 3x times another negative 3x is positive 9x squared. And so my ratio is negative 3x. My first term is 1. And that means that my function, or my rational expression for f prime, would be my first term over 1 minus the ratio. And that would only converge, that would only work for x's when that ratio is less than 1. So x is between negative 1/3 and 1/3, but they didn't ask you to specify that. I'm just rambling now. Let's see. And the last one, part E, those first two are really quick, so I'm going to go ahead and do part E. Part C also, it starts by saying, write the first four non-zero terms for e to the x. So e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And then it says, write the third degree Taylor polynomial for e to the x times f of x. So if I do e to the x times f of x, that would be approximately e to the x, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus times my function for f, which now I've got to scroll up. F is x minus 3 halves x squared plus 3x cubed. And it does go on beyond that, but we are looking for the third degree Taylor polynomial. So what I'm going to do is expand that expression, and I'm going to have to expand to make sure I get all of my terms that are third degree or higher. So I'm going to start with the 1. I'm going to distribute the 1. So this is going to be x. Actually, I'm going to do that'll be fine. X minus 3 halves x squared plus 3x cubed. And then I'm going to distribute my x. X times x is x squared. And I'm going to go do this, line them up vertically and match up my my like terms. So x times x is x squared. X times negative 3 halves x squared is x cubed. X times 3x cubed would be 3x to the 4th, but I don't care because I want the third degree Taylor polynomial, so I'm actually going to ignore that piece. We're going to go only so far as I get my third degree terms. Distribute my x squared over 2 factorial, so x squared over 2 factorial times x would be x cubed over 2 factorial, so that'll be 1 over 2 factorial x cubed. And if I expand any further, x squared times x squared will be x to the 4th, and I don't care. And if I try to distribute my x cubed over 3 factorial, I will get everything larger than a third degree polynomial. And so now we need to add all of that together to get my third degree Taylor polynomial for e to the x f of x. And so I have x, and there's nothing to combine with that. I have negative 3 halves plus 1 would be negative 1 half. And then I have 3 minus 3 halves plus 1 half. Negative 3 over 2 plus 1 over 2 is negative 1. So that's 3 minus 1. So that would be 2x cubed. And there is your third degree Taylor polynomial for e to the x f of x. Let's make sure I answered everything. Use Maclaurin series for e to the x, write a third degree Taylor polynomial for e to the x f of x about x equals 0. And there we have it. So that is all of this free response question. What was it? 2015, number 6.